Hey everybody. So here in this problem they say if the area of the gray shaded region in the diagram below is 103 square feet, what are the dimensions of the inside rectangle? Okay, so we're dealing with area, so we know that area is the length times the width, but they tell us that it's the area of this gray shaded region is 103 square feet. So here's what we're going to have to do. We're going to have to find the area of the larger rectangle and subtract the area of the smaller rectangle. That would give us the area of the gray shaded region. So here we have this length times this width. So this is going to be 3x minus 2 times x plus 6. And what we're going to need to do is subtract the area of the smaller rectangle. So that's going to be this length, 2x, times x minus 1. The use of the bracket here is not overly important. What I'm doing is I'm showing you how that I have to subtract this product. So I need to multiply these together first, then subtract it. So here's the area of my larger rectangle. Here's the area of my smaller rectangle. This difference should equal 103 square feet. So here I have 3x times x. That's going to give me 3x squared. I have 3x times 6. This is 18x. Negative 2 times x. Negative 2 positive 6 is negative 12. Minus, now I have 2x times x. This is 2x squared. 2x times negative 1 is negative 2x. This should equal 103. Now I need to take my negative and distribute here. So I have 3x squared. I'll go ahead and say 18 minus 2x. This is going to be 16x minus 12 minus 2x squared plus 2x equals 103. Now remember, this negative went to the 2x squared, and it also goes to the negative 2x. So now I have more terms to combine. I'll also go ahead and take the 103 and bring it over to this side so I can set my quadratic equal to 0. So 3x squared minus 2x squared just gives me x squared. So those are done. I have 16x plus 2x. This is going to give me 18x. So my x's are done. Negative 12 minus the 103 is negative 115, and this will equal 0. So now here's the quadratic that I'm solving for. So now that I'm solving, any method in applications you can use, right? They're at your disposal. So you can use factoring, you can use the AC method, which is just another form of factoring. We use it when a is greater than 1. You can use completing the square, or you could use quadratic formula. So here's what I'm always going to recommend. If it is factorable, factor. That's the fastest. If it is not factorable, go straight to quadratic formula. It is always right, and it always gives you the zeros. Okay? Now, here is a trick. You can know if it is factorable whether the discriminant is a perfect square or not. So we've talked about that before. Okay, the discriminant, that is b squared minus 4ac. This is the value of the discriminant. If this value is a perfect square, this is factorable. So this is something that's really easy to test. So b squared is 18. Or excuse me, b is 18. So I'm going to say 18 squared minus 4 times 1 times negative 115. So on my calculator, I can say 18 squared minus 4 times 1 times negative 115. This is going to give me 784. Okay, can I take the square root of 784? And that answer is yes. So if 784 is a perfect square, that means this is factorable. So you can go ahead and take the factors of this. So I could write this out. So here I have x and I have x. Signs are different. The larger number is positive. So now I'm thinking, what numbers multiply to give me 115 that I can subtract, and I will get positive 18. And that's going to be 23 and 5. So now I can set each of these equal to 0. So I know that my values are going to be x equals negative 23 and x equals 5. Now, here we're talking about a value I can substitute in here. Okay, negative is not going to work because if I plugged it in here, what's negative 23 plus 6? It's still a negative number because it's negative 17. You can't have a distance that is negative. So this negative 23, this does not work. All right, we cannot include the negative 23. So here we're just going to say 5. So x is 5, but they said what are the dimensions of the inside rectangle? They didn't say solve for x. So here I'm just going to take 5 and plug it in. So this width is 5 minus 1. So here the width is 4. The length is going to be 2 times 5, which is 10. All right. So those are going to be my solutions. Okay, let's look at another popular type of a quadratic application. Okay, so here in this example, we have the product of two positive consecutive integers is 132. Find the two integers. Okay, so let's think about what we're saying here. Positive numbers, this is nice because now we're not dealing with any negatives, so our answer cannot be negative. Consecutive means one right after the other. So I have two positive consecutive integers. All right, what's the first number? Okay, so we're going to let that equal x. Okay, the second number we also don't know, but we know that these are consecutive integers. So just like if I said pick a random number and you said 47 and I said, okay, what's the next consecutive integer? It has to be 48. Okay, so here this is just going to be x plus 1. So here's some number, and then here's the next consecutive integer. Now they tell us the product of these two is 132. So product means multiply. So if I said x times x plus 1, this would give me 132. Well, now I have a problem I can easily solve for x. X times x is x squared. X times 1 is x. This equals 132. Well, now I can just subtract this to get my quadratic. X squared plus x minus 132 equals 0. Now here's the quadratic to solve for. So you have all your methods. Remember, with your applications, if it is factorable, factor it. If it is not factorable, go straight to quadratic formula. So here, let's see if this is factorable. I'm going to wager that it is. So I have x and x. Now I'm looking for numbers that can multiply to give me 132. And when I combine them or subtract them here, I'm going to get positive 1. So those numbers are going to be 12 and 11. So positive 12 times negative 11 gives me the negative 132, and then 12 minus 11 gives me the 1. So here, when I set these equal to 0, I have x equals negative 12 and x equals 11. Okay, well, we know the negative's not going to work because they say positive consecutive integers. So here, this is wrong. So x is 11, and then the next consecutive number is positive 12. So your two numbers are 11 and 12. All right? So in the next example, it says find 3 positive consecutive integers such that the product of the first and the third integer is 17 more than 3 times the second integer. Okay, so we can talk about this. 3 positive consecutive integers. Okay, so the first we can let be x. The second is going to be x plus 1. And the third is going to be x plus 2. So here are my 3 consecutive integers. Now they tell us the product of the first and the third. Okay, we can go ahead and write that out. X times x plus 2 is, okay, so that means equal 17 more than 3 times the second integer. Okay, 3 times the second integer is 3x plus 1. So here's 3 times the second integer, and then it says 17 more than 3 times that. Okay, so I take this product and add 17. So the product of the first and the third, x times x plus 2, is 17 more than 3 times the value of the second integer. So I have this set up. Now I'm just going to distribute, combine like terms, and then I'll solve my quadratic. So here I have x squared plus 2x equals 3x plus 3 plus 17. So now I need to write this out like a quadratic. So I have x squared, 2x minus 3x is negative x. 3 plus 17 is 20. I want to move it to the other side. So this is going to be minus 20. This will equal 0. So here I'm going to try to factor it. If it is not factorable, I will use quadratic formula. So here I have x and x. I need factors of 20 that I can combine to get negative 1, and that will be negative 5 and positive 4. So my x's here are 5, and x equals negative 4. They tell us these numbers have to be positive, so this negative 4 is wrong. So my consecutive integers are 5, 6, and 7. All right, and that's how we can use quadratics to find consecutive integers. All right, lastly, we can use quadratics in applications when we are talking about upward initial velocity, right? So anytime I'm talking about, we'll say a parametric equation, all right? I have an object, it goes up in the air, it changes direction and begins coming back down and then eventually hits the ground, right? Anything like that, because it looks like a quadratic. I have some object that goes up into the air, it changes direction, comes back down, and then hits the ground. This looks like a parabola, so I can use quadratics to find values here. So in this problem, they tell us a soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second. The equation, h equals negative 16t squared plus 90t, gives the height h of the ball after t seconds. Find the maximum height of the ball. All right, let's look at what we have here. So here I have some soccer ball. It's kicked into the air, it changes direction and comes back down and hits the ground. Okay, where it starts and then where it ends after hitting the ground, these would be zeros because the height would here be equal to 0. Okay, so here we have height and we have time that it's in the air. They want us to find the maximum height of the ball. Okay, well here, this is going to be our maximum height. It's going to be that y value. Okay, so what I need to know is at what time will it reach that maximum height? Okay, because I'm going to plug that value of t in for this. Well, if this is the highest point on a parabola, we know what that is. That is called the vertex, because the vertex is going to be the highest point or the lowest point. And we know how to find the x value of a vertex, because we would have to find the axis of symmetry. So if you don't remember that, that is x equals negative b over 2a. This is what we need to find where or at what time the ball will have a maximum height. So here my b term is 90, so I have negative 90 over 2 times negative 16, my a here. So I have negative 90, this is over negative 32. So let's find our x. So here, this is going to be 2.81. So at this time, at this many seconds, the ball will have a maximum height. So this is 2.81. Now I'm going to take this value of time and plug it into my equation so I know this y value. So here I have negative 16 times the time squared. So this is 2.81 squared plus 90 times 2.81. So here we have negative 16 times 2.81. That value is squared plus 90 times 2.81. And I get 242.40. And this would be feet. All right, so at 2.81 seconds, this ball had a maximum height of 242.40 feet. Okay, so that's how we can use the axis of symmetry to find heights. Here, they want us to know, or they ask us, how many seconds will it take for the ball to reach the ground? Okay, so at 0 seconds, it's on the ground. How much time passed before it hit the ground right here? Okay, well, let's think about it. When the ball is on the ground, that's a 0. So I'm finding the zeros of this quadratic. So here I have negative 16t squared plus 90t equals 0. So remember, when you have two terms, you always want to check for GCF. We're always looking for the greatest common factor. So I know I can factor out a t. What else could I factor out? What is the largest number that goes into 16 and 90? And I believe that's going to be 2. So here I can factor out a negative 2t. And this leaves me with 8t minus 45 equals 0. Now, here I set each of these equal to 0. So I have negative 2t equals 0, and I have 8t minus 45 equals 0. So here, when I divide by negative 2, t is 0. Now, this makes sense. At 0 seconds, the ball is on the ground. Obviously, just like here, at 0 seconds, it's still in a resting position. So now my next 0 will tell me when it hits the ground. So this is going to be 8t equals 45. So t here is 45 over 8. So if I wanted that as a decimal, that's going to give me 5.625. So at 5.625 seconds, we'll include our unit here. This soccer ball is going to hit the ground. All right. That's going to be all for this video. I hope that you found it helpful. I know that we covered a lot of content. If you have any questions, please leave them in the comments, and we'll see you all in the next video.